Hello. In this video we are going to look at how to answer a exam question assessing the specific heat capacity required practical. This is from the Specimen paper, so it's not actually been on a GCSE paper yet. So the first part of the question asks us to draw a label diagram showing how the apparatus used to determine the specific heat capacity of aluminium should be arranged. So just make sure we're using good exam technique. You want to surround your keyword. So we're going to put a box around the word draw and underline the word label, because we have to draw a label diagram. If you don't do that, you're not going to pick up 3 marks. We also need to make sure that we include that this is for aluminium and that it's going to allow us to calculate specific heat capacity. So they're the basics. The diagram that you want to draw is one that looks like the picture that I showed you at the start. So it should look like this picture here. We've got a power supply, which is connected to a joule meter, which is then connected to a heater, which goes into a metal block. In this case, it will be aluminium. And then we've got a thermometer in here to record the temperature. So let's have a quick go at doing that. So it doesn't need to be expert, it just needs to be a label diagram. So if we want to draw something like this to represent our power pack. Now, if we noticed in the video before, we had to have 2 wires coming out of the power pack in order to make a series circuit. And that is then going to be connected to the joule meter, which is something like this. All right, put a little display on it just to show it's a joule meter. And then that joule meter is then connected in series again, so these wires are continuing, to a heater. And this heater element is going to go into your block. Now in this case, the block is aluminium. So if we just draw the block like this. Now in order to calculate specific heat capacity, we're going to need to know the formula. So we know that it is the change in energy is equal to the mass of the object times by the specific heat capacity times by the change in temperature. So we need to make sure that we can find all of these things. So in order to find the change in temperature, this part, we're going to need a thermometer. So in our diagram here, we are also going to need a thermometer. If we just draw some bits up the side. In order to make this experiment fair, you are going to have to put some insulation around here. I've just used the word fair, which is something I should have said I should never do. What I mean by fair is that we shouldn't be saying fair, we should be saying that in order to make our results comparable and reliable. So we've got A, and we're going to label these now. So we've got a power pack, and this is connected to a joule meter. And the joule meter is going to do this part. This is going to calculate the change in energy for us. That is then connected again to a heater. The heater is in a block of, if we have a look, it's aluminium. If you write metal block, you won't get the mark there. You must write aluminium. The aluminium is surrounded with some insulation. That's to keep the heat that you're supplying from the power pack. That energy needs to stay as much as possible in the metal block, because any that's lost to the environment will mean that we get an incorrect reading for our specific heat capacity. So we've labelled almost everything. The only thing we need to label here is the thermometer. There we go. So we've got a very crudely drawn, but would get you all of the marks diagram of how to set up this equipment. So we've got a power pack connected in series to a joule meter, connected in series, I better make it link, to a heater, and the heater is inside a block of aluminium. The aluminium has got a thermometer in it so that we can calculate the temperature, and then we've got some insulation on the outside. The only thing that we haven't got here is something to calculate the mass, so I would just draw on something like this just to show that you understand that you need to calculate that mass. Okay, and this is an electronic balance. Okay, perfect. There we go. Okay, so the next part of this question is the one where you are going to have to actually write a method and describe how you're going to use the equipment that you have drawn in order to calculate the specific heat capacity of aluminium. So first things first, again, we need to annotate our question. So we're going to box around our keywords. So the keyword here is describe. That means that you just need to write a logical and just need to say what you're going to do. You don't need to explain why you're doing it. And in order to determine the specific heat capacity. So whenever we're writing a 6-mark question or an answer that is describing a method, we want to use an acronym. We're going to use this one. This is MARV, and MARV stands for method. There we go. Apparatus, risks, and variables. Okay, so if we include all of these things in our write-up, we should score very highly and get as close as possible to the 6 marks. Now, I've taken up most of my exam paper here, so you don't need to do that. I would just leave the MARV somewhere on your paper though, so that you can remind yourself, and you can use it as a checklist when you're writing your exam question and when you're writing your answers. So first off, we're going to start with a method. So let's have a go. Because we've already drawn the diagram, all we need to do is we just need to say set up the equipment as shown in the diagram. So we'll write that. That is step 1, so it would make sense to put the fact that is step 1 here. So set up the equipment as shown in the diagram. I'm really going to apologise for my handwriting. It is normally quite good, but when I'm writing it on a computer, it tends to get a bit scruffy. So step 2. What we need for step 2 is a little bit more planning. So as well as MARV, another thing that might help you is you're trying to figure out the specific heat capacity. So I would write the formula on there that you're going to use. So it's on your data sheet. So it's the change in energy is equal to the mass of the object times by the specific heat capacity times by the change in temperature, which is represented by this symbol here. If we mention all the steps that we're going to do in order to find mass, change in temperature and change in energy, then that will allow us to find this. So we're going to have to mention how we're going to find all of those things. The first thing we should mention, and probably the easiest thing to do, is that we are going to find the mass. So we'll start out with the mass. So I'm going to box that to show that I've done it. So find the mass of the aluminium using now if you're looking at our diagram, we use an electronic balance. So we'll use that. Find the mass of the aluminium using an electronic. Okay, technically you want to do that in kilograms, but I don't think we need to say that for this experiment. But if you add it in, that's absolutely fine. So we found the mass. The next thing we need to say is how we're going to find the change in energy, or how we're going to find the change in temperature. The thing is, there's not going to be a change in temperature unless we leave it running for a certain amount of time. So that's the next thing we should say. We should say 3. Set the experiment running for, I don't know, it's up to you, 30 minutes. And we need to say how we're going to figure out the change in energy. So if we set the experiment running for 30 minutes, we're going to use the joule meter. So we're going to use the joule meter to record the amount of energy transferred during that time. So set the experiment running for 30 minutes, use the joule meter to record the amount of energy transferred that is terrible. We'll try that again. Transferred okay, so set the experiment running for 30 minutes and use the joule meter to record the amount of energy transferred. Step 4. So we've said how we're going to find the change in energy, so we'll put a square on that. That one has been done. The last thing we need to do is talk about how we are going to find the change in temperature. So step 4 is use a thermometer to measure the temperature before and after heating the block. Really, we probably should have said this here because it needs to be followed almost like a recipe. So you should be editing your work. If you notice this, like I just have now, I would probably add a little section in here which said record the initial temperature. So I'm going to do that here. So record using a, you have to make sure you mention the equipment. So record the initial temperature using a thermometer. So therefore I'm just going to rub these out and I'm going to change my order. So find the mass of the element using an electronic balance. 3 would be to record the initial temperature using a thermometer. 4 would be to set the experiment running for 30 minutes, use a joule meter to record the temperature. And then 5 is to use a thermometer to measure the temperature. Now we've already said before, so we can cross that out. After heating the block, subtract the final temperature from the initial temperature to find the change in temperature, which is this. Okay, let's have a look. So we've done that, and we have done that. So now we just need to say how we're going to find this. So step 6 is to use the formula change in energy equals mass times specific heat capacity times by the change in temperature to calculate the specific heat capacity of the aluminium. Oh, spelling A-L-U-I. Try again. There we go. So use the formula to calculate the specific heat capacity of the aluminium. You don't need to say how to rearrange it. You just need to say that you're going to plug your values into that formula. If there's a question that's going to be assessing your maths, it will be a maths question. Okay, if we now go back to our plan, we have talked about all these things. So let's start to look at our math. So have we given a method? Yes, we have. So we can cross that out. We've done that. Have we mentioned apparatus? All right, so we've said we're going to use electronic balance. That is good. So we've done that there. We have said we're going to use a thermometer here. Good. We've said we're using a joule meter. That's fine. Again, we said a thermometer. Yep, so we have mentioned apparatus all the way through. Have we mentioned any risks? No, we haven't. So that's something we now need to do. Okay, so the risk in this experiment is that the heater is going to get hot. So don't touch it. That's it. So risk, and I've just labeled it as risk. You might as well tell the examiner where to look. So that's my risk. If they want to look for a risk, here it is. So risk, the element will get hot, so avoid touching it with your hands. Okay, let's look back to our MAV. So we have now talked about risks. The last section was variables. I also forgot to mention that the V should also stand for valid results, because you should always say in a method how you're going to make sure that this is accurate, and how you're going to make sure that your results are repeatable and reliable. So let's have a go at doing that. So in terms of variables, it's a bit of a stranger experiment, this one. There's no independent variable because you aren't changing anything. The independent variable is actually time. The only thing that's changing is you have turned the heater on and you're letting it run for an amount of time. So if you were to draw a graph, it would be a time that would go on the bottom. In terms of the dependent variable, what you're measuring, we're measuring the change in temperature, and we're using that to calculate specific heat capacity. So we have mentioned that. And in terms of control variables, we haven't really mentioned those, but again, there's nothing too much that we do need to control in this experiment. What we should do though is we should talk about how we're going to make it more valid. And in any experiment, the way you make it more valid is that you do it multiple times. The more times the better. And then you take your results and you calculate a mean, which will allow you to spot any anomalies, and it will also allow you to just make sure that your results are as accurate as possible. So let's just add that on. So we'll just put that in here. So repeat the experiment. It's your method, so you can tell them how many times you want to do it. So repeat the experiment 3 times and calculate a mean. Right, there we go. Repeat the experiment 3 times and calculate a mean. That's about as much as we need to do. The third and final part of this question says, methods used to determine specific heat capacity of aluminium may give a greater than the actual value. Explain why. This is an explain, so we're going to have to give scientific reasons for our description, but it's only worth 2 marks, so we don't need to say a lot, even though there is quite a lot of lines given here. Don't be tricked by the amount of lines. Look at the marks. With this experiment, the biggest source of error is going to be here. I'll scroll up to it. Our biggest source of error is going to be around this metal block and the amount of energy that is transferred to the surroundings. So what we're going to say is not all of the energy input, so not all of the energy transferred to the metal block will be used to increase the temperature of the block. Some will be to the surrounding. Okay, apparently I can't write in the lines. So, not all the energy transferred to the metal block will be used to increase the temperature of the block. Some will be transferred to the surroundings. So that's our reason, and now we have to explain why that's a problem. And the problem will be is that the formula, the change in energy, which is measured by the joule meter, equals mass times specific heat capacity times by the change in temperature, assumes all energy inputted by the joule meter, by the power pack. So it assumes all energy input by the power pack is used to change the temperature of the metal block. Okay, so basically the specific heat capacity value that we calculate is going to be different than what it is in reality, because not all of the temperature change is actually happening. So we'll definitely get all of the energy measured correctly that we're putting in. So this value here will be right, but this value here will be lower than it actually is. And because that's lower, it's going to mean that this specific heat capacity value is inaccurate. Okay, so it will actually produce, as it says in the question, it will produce a greater value than the actual value. Okay, so this is quite a long video, 21 minutes apparently, but hopefully I've explained that question really well and you understand it. It might be interesting to see that even as a teacher, I am, when I'm writing it, having to go back and reread my answer and correct it, and you're still going to make mistakes. So don't worry, your answers don't have to be perfect, and if you make a mistake in the exam, just cross it out, single line straight through it, because if you do that, the examiner is still allowed to look at what you've actually crossed out, and they can give you credit for that. If you put a big line through it and color it in so that they can't read it, then you're not going to have any chance of doing that. But you can always ask for paper if you need it. The key is just to learn these practicals and almost just know them off the top of your head so that you can answer them whichever one comes up in the exam. Okay, good luck.